This lesson is about solving systems of equations. This time we're going to use substitution. Okay, we talked about the solution. To solve it, we're going to find the point the two lines have in common. One method to do that was, of course, graphing the lines and seeing where they cross. There are other ways. Another way is called substitution. What we do with substitution is either the y or the x variable is going to be replaced with an expression that's equal to it. In order to use this method, you may have to rewrite one of the equations to isolate one of the variables before you begin. For instance, if the equation I started with was 2x plus y equals 7, neither of the variables are isolated, so I would need to subtract 2x from each side so that y is isolated and I get the equation y equals 7 minus 2x. So we want to solve this system. We're going to use substitution to do that. Looking at the two equations, one variable has no coefficient on it, so that's a great candidate to solve for. So in the first equation, I'm going to get y by itself. So I'll add 3x to each side, and now the first equation has been transformed to y equals 3x plus 9. Now that I have transformed that equation to y equals 3x plus 9, where the y appears in the second equation, I can replace it with 3x plus 9. So instead of 4 times y, I'm going to take 4 times the quantity 3x plus 9. We'll distribute the 4, combine the like terms, subtract 36, divide by 14, and we have x equals negative 2. Now that we know that x equals negative 2, we use that to solve for y. So we substitute negative 2 in for x in one of the equations. I happen to pick the second one. I could have picked the other one. Multiply and I get negative 4. Add 4 to each side. I get 12. Divide by 4, y equals 3. So the solution to this system is negative 2, 3. The next one, I'm going to solve this one. Y is already isolated. I know that wherever y is, I can put 3x in its place. So where the y is in the second equation, I'm going to replace it with 3x. Now I'll multiply, combine my like terms to get 7x, divide by 7, and x is negative 3. I plug that back into another equation, and then I know that when I solve this, y equals negative 9. So my solution to this system is negative 3, negative 9. We're going to use substitution to solve this system. As I look at the different candidates for a variable to isolate, I notice the x in the first equation has no coefficient, so that's the one I'm going to isolate. To isolate that x, I'm going to add 3y to each side. Now this tells me wherever there's an x in the second equation, I can take it out and put the replacement of 3y plus 3. So I'm going to take the x out and I'm going to put 3y plus 3 in its place. Use the distributive property, combine my like terms, subtract, and y equals 1/3. Now I take that 1/3 and put it in one of the equations and solve for x. So if I put 1/3 in the second equation, 1/3 of 9 is 3. I'll subtract 3, divide by 2. And so the solution to this system is 4, 1/3. We're going to solve another system of equations. The y is already isolated in the second equation, so I don't need to do any work. So I go ahead and substitute for the y. I put 3x minus 3 in its place. I'd be distributing a plus sign. So now I'm going to combine my like terms, and I get negative 3 on the left side, negative 2 on the right side. Never is negative 3 equal to negative 2. This tells me that there are no solutions to the system, and the system would be inconsistent.